required to find the constant term and its value in the given exponential expression. Using the binomial formula expansion, the product of n combination r, p rise to the power of n minus r, q rise to the power of r. Here, n equals 20, p equal the product of 2 and the cube of x. Also, q equals -1 divided by 3 times the square of x. Ignore the n combination r as we do not need it to find the term where the exponent of x equals 0. Thus, the product of p rise to power of n minus r and q to the power of r equals the value shown on the screen. Simplify these values by separating coefficient of terms, leaving only values of x. Equate the x values to x to the power of 0 and then simplify powers using laws of indices. Hence, x rise to power 60 minus 3 times r minus 2 times r equals to x rise to power of 0. It implies that x to the power of 60 minus 5 times r equals to x to the power of 0. Equal base cancel out, and thus, we equate the powers. 60 minus 5 times r equals 0. Solve for r and we have that 5 times r equals 60. Divide the equation by 5 and hence, r equals 60 divided by 5, which equals to 12. Therefore, the required constant term is the 12th term. For the solution to question 2, let us find the value of the 12th term using the same formula, the product of n combination r, p to power of n minus r and q to the power of r. Here n equals 20 and r equals 12. Thus, substitute values in the formula and simplify to obtain the required value to be equals to 107,49440 divided by 177,147.